In this video, we're going to see about the volume integral. So we're going to do a practice problem on the volume integral and see how we can apply, we can do these problems. So volume integral. So in this question, we are asked to evaluate the volume integral of del dot f. This is so volume integral of del dot f we are asked to evaluate, where f is nothing but, where f is given as, f is a vector and it's given as x square I plus y square j plus z square k. And the volume, the given volume, so this is the, you're asked to integrate over a volume, and the given volume is a cube, is a cube, is a cube, it's a cube bound by the region, cube bound by the region x equals 0 and x equals 1, and y equals 0 and y equals 1, z equals 0 and z equals 1. So this is nothing that the length, breadth and height of the cube, you can take it like that, and the length and breadth and height are all 1. So just you have to evaluate the volume integral of such a cube with this function del dot f. So this del dot f is nothing but the divergence. So the divergence is always the resulting the result of a, when you compute the divergence, you get a scalar. So because when you compute a divergence over this vector quantity, what you're doing is del is nothing but this quantity I dou by dou x j dou by dou y plus k dou by dou z, and you're taking a dot product with the f. So x square I plus y square j plus z square k. So this is the what you're taking the dot product over. So when you take the dot product, the I into I will become I square, which is nothing but 1, j into j square 1, k into k square 1, and you have to evaluate the this differential operator. So the differential operator operated on x. So the differential operator operated on x is nothing but 2x, and on y is nothing but y square is nothing but 2y, and on z, when dou by dou z acts on y square z square, it is nothing but 2z. So this is the resulting. This is what is the divergence of f. So the divergence of f. So we have to compute the volume of volume integral now of this divergence of f. So this is our divergence of f. Let's write out the volume integral. So the volume integral, the divergence of s is this given quantity. 2, we'll pull it out as a constant. So 2 is common here, so we'll pull it out as a constant outside the integral. Put it out here, and x plus y plus z, and it's a volume integral. So the integration element will be dx dy dz. So this is the volume element, and the integration limits, for x it goes from 0 to 1, from y it goes from 0 to 1, and z it goes from 0 to 1. So this comes from here. We are given the integrate, we're given that the cube is bound by these regions, so we have the limits. Now we just have to integrate. So first integration with respect to dx, integrate it as everything else as a x as the integration variable, everything else as a constant. So what you get here first time is x square by 2, because you're integrating with respect to x, and then everything else is a constant, so just add x to it, right? So when you integrate a constant, you just add x to it, right? So that's what you're doing, xz. So this is 0 to 1, and you have the other two integrals outside. Okay, so this should remain, so dy by dz. So now this just becomes, when you substitute upper limit minus lower limit in the place of x, only in the place of x you have to substitute. So when you substitute that, this integral just becomes 2, 0 to 1, 0 to 1. So this just becomes 1 by 2 plus y plus z. So now this you have to integrate with respect to y now. You have to integrate with respect to y now. So integrate with respect to y. So when you integrate with respect to y, so the z integral remains and you're integrating with respect to y, and you get y by 2, y square by 2, and plus yz. So dz. And upper limit minus lower limit, upper limit minus lower limit. So upper limit minus lower limit here in this case would be just, so the outer integral remains and the upper limit minus in lower limit. So in the place of y, you do the upper limit minus lower limit. So that is half plus half plus z. So that is your upper limit minus lower limit. So here you have an integration again, now only with respect to z. So only the variables that remain are with the z, so integrated with respect to z. So this is nothing but, when you evaluate this integral, so you have the 2 remains outside and we have half times z, or z by 2. Okay, so z by 2 plus another z by 2 plus z square by 2, and upper limit minus lower limit. So in the place of z, you do the upper limit minus lower limit. What you get, the answer is nothing but for this is 3. So this is your required integration. So volume integral, we've computed the volume integral of this quantity and the answer is 3.